Hello, Honors Algebra students. Mr. Lawrence here, and I put together a quick review video. Now remember, some of you are just trying to figure these out like you're supposed to know the answers. You're not supposed to. You're supposed to be able to figure them out. You're supposed to be able to take some specific actions, some specific steps in different situations, different steps, and discover what the variable equals. Okay, so I'm going to go through my questions. Do you remember the question? The first is, what is my goal? Right? And that's to get the variable alone. Okay, this is solving a variable in one equation. Excuse me, an equation in one variable, a linear equation, if you will. All right, 2 is what numbers are keeping the variable from being alone? What numbers? I'm just full of typos in here, sorry about that. Keeping the variable. Oh my goodness, just spelling everything. Form, look at this crazy business, from being alone. All right, third question I ask myself is what how are those numbers attached to the variable? And that will always be answered with an operation, right? An operation will always do that. I think my view is too big here. Let me zoom it out so you can see more. There we go. That's a little bit better. All right, and 4, how do I undo those operations? In other words, what are the inverse operations? That's what I'll undo it. You know, multiplication undoes division, division undoes multiplication, etc. Okay, and the final question is, which operation should I undo first? And that's where we listen to Saddam. We undo going through the reverse order of operations. We undo subtraction and addition, then we undo division and multiplication. So let's try a problem like this. Now, there's two things going on in this problem. One, there's a whole bunch of fractions. Well, I'm going to multiply to get rid of my denominators. Yeah. I got to find the smallest number that 2, 3, 4, and 5 go into. So I'm going to count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Oh, I'm not finding a number. Jiminy Christmas. 45, nope. 50, 55, 60. 60, I think that's it. 60. I'm going to multiply everything by 60. Why 60? Because it's the smallest number that 2, 3, 4, and 5 go into. Yeah, so I'm going to multiply by 60 over 1, and here I'm going to multiply by 60 over 1. I'm distributing, right? And then by 60 over 1, and then by 60 over 1. So this here, 2 goes into 60 30 times, becomes 30x. This part here, 3 goes into 60 20 times, now I have minus 100. Excuse me, 4 goes into 60 15 times, 7 times 15, I think it's 105. I think that's right. And then 5 goes into 60 12 times. There's a 2x here, so this is going to be a 24x. Now I have variables on both sides of the equation, so I'm going to get rid of one of them. I recommend getting rid of the smallest one. It'll save you a step in many cases later on. So when I do that, I get 6x minus 100 equals 105. Now I'm going to add 100 to both sides. And I'm going to get 6x equals 205. And then I'm going to divide by 6. Now, I know this can't simplify. I could give my answer as this, although it doesn't mean a whole lot to me, so I may convert it to a mixed number. And I'm going to see how many times does 6 go into 205. It's going to be a lot. Let's see, it's going to be 30-some, 18, and that will be 25, just doing a little long division. 6 is going to go to 25 4 times, so I'll have 24. There's going to be 1 left over. So this is going to be 34 and 1/6. Either answer is acceptable. I like this answer better because it makes more sense to me in this problem. If you didn't understand that, please make an appointment coming to see me. Next help session is Monday. All right, there's my questions. You can always go back to them. All right, in this situation, I've got two quantities. And since the number being distributed here is a 5, and that's a 10. I can divide both sides by 5. This will make my life a little bit easier. 5s will cancel, and here the 5 will go into the 10 2 times. So on the left-hand side, I'm going to have 3x minus 1. On the right-hand side, I'm going to have 2 times the quantity of 5 plus 2x, excuse me. I have to distribute on the right-hand side now. And so we're going to go 3x minus 1, which will equal 10 plus 4x. I've got variables on both sides. I don't like that. I'm going to take away the smaller one. I'm going to subtract 3x from both sides. And when I do so, I will get negative 1 equal to 10 plus x. I'm going to subtract 10 from both sides. I'm going to get negative 11 equals x. And there you go. All right, a couple more examples here. Here's one where if you look at the right-hand side, you might notice something. What do I have on the right-hand side? I have like terms. Like terms simply combine. So many of you want to start subtracting x from both sides. I wouldn't do that. I would just combine my like terms and rewrite the equation as 12x minus 7 equals 7x plus 5. 6x plus 1x, 7x. Now, I'll take away the 7x. Remember, I want to get rid of the smaller one. It makes my life easier. And I will have 5x minus 7 equals 5. Well, now I'll add 7 to both sides. Listening to Saddam, going reverse order of operations. And then I'll divide by 5. And x will equal 12/5. If I want to go mixed number, I'll have 2 and 2/5. Whichever answer makes more sense to you. If you understand this answer, go ahead. You're done. All right, here's another one. I can't divide, well, I could divide through on this one, but I'm not going to show you too much at once. I'm going to lose some of you because I could divide by 3 here, and I could divide by 3 here and here. There's a 3 factor hiding in here. But I'm not going to do that in this one. I'm going to distribute first, and I'm going to get 6x minus 15. And then I'll have a negative 15 plus a 6x. All right, they're the same size, so I'm going to subtract 6x from both sides. And I'll get negative 15 equals negative 15, which is always true. There's no variable. X is not negative 15. There's no x here to say x equals something. This is always true. This means that any real number will work in this equation. We can call this an identity. Identity. Yeah, it's really the same equation on both sides. It just looks different, okay? But once you distribute, you realize you get the same thing. And then, of course, you use the commutative property here, and you can see you'll have 6x minus 15. All right, so that's a situation. You got a statement that was always true, no variables, it's always true, and then any real number will work. All right, how about this one? Well, let's start by subtracting 7x from both sides. And then I'm going to get negative 4 equals 2. Does negative 4 ever equal 2? No, it doesn't. This is a situation where there is no solution. Because you got a situation that is never true. There is no number, x, on the entire number line, considering all the rational and irrational numbers, that will make this statement true. Try it. Put 0 in for x. You'll get negative 4 equals 2. That's not true. Put 1 in. You'll get 7 minus 4 is 3. 7 plus 2 is 9. Nope, not going to work. Any number you try, it will not work. There is no solution. All right, one last problem I want to talk about, and that would be one where we have something like this. To do a problem like this, your first step is to multiply. Why? Because this 4 is being divided into the 3x and into the 2. This isn't a 2, it's a 1/2. This isn't a 3x, it's a 3/4 x. But if I multiply by 4 over 1 and multiply by 4 on the other side, my 4's can cancel out, thereby freeing up my numerator, making it just 3x plus 2, and now it looks like a simple two-step equation. And I think if you finish solving that, you're going to find that x is 6. Okay, I'm going to let you solve that. All right, now this, I went talked really fast. Go through this video again if you need to. Watch the parts you don't understand. Come in and ask me questions about it. Come in Monday after school. I would love to help you. All right, Mr. Laurence signing off. Have a good night, everybody.